Meltzer from the Institute of Computing for Climate Science, who's going to be talking to us about debugging HPC applications. And I think you're going to do a bit of presentation and a bit of work through. So questions after the presentation, and then
questions at any point
as you want. Yeah, excellent. Yeah. In that case, yes, take it away.
All right. Okay, yeah, welcome everyone. Thanks for coming to my talk. I could have also titled this talk, "Hey, I've made a really cool tool and I want to share it with everyone." And that would also be valid, but I thought I'd lure you in a bit. So I'm going to be talking about HPC applications. And the reason I made this distinction is there are many tools for debugging programs, but my specific focus as a scientific software developer is I typically work on remote machines. So supercomputers in other parts of the world. I'm not normally I don't have physical access to the machines I need to run code on. And the other distinction is typically, although developers may develop the code locally before they then run it on a HPC, typically the runtime environment of those codes lives on the HPC. So if there's problems that only occur on that computer, that's where you need to be debugging. So that's why I've titled it this way. So I want to give an overview of the talk today. So I kind of want to hope to kind of present some of the benefits of using debuggers, because they're not the only means to debug programs. And to that end, I'm going to focus on a couple of specific debuggers. So I use GDB a lot. I'll talk a bit about what GDB is in a minute, and I'll also go through a demo of GDB. But then one of my main focuses of the talk is going to be on my live demo. So I've created a tool called MDB, and it's kind of like an MPI-aware debugger. So I felt like there was a sort of gap in the open source software space where I didn't have kind of nice tools for debugging MPI programs. So yeah, what is a debugger, first of all? Well, it's a program that can be used to test or debug another program called the target. And the whole point is that target program is run in a controlled environment. And it allows the user and the debug tool to kind of inspect resources, interrupt the program runtime, and even maybe modify code execution. So yeah, we're going to get started with GDB. Now, I learned this for this talk actually, but the logo is, fun fact for you, the logo is a little archerfish. Okay, and they're known for being able to shoot little jets of water and knock bugs out of hanging branches and shrubbery. So yeah, that's Frank the fish. Okay, so GDB. So if you go to the man page, this is a slightly abridged version of the man page. It's a new debugger. Okay, so the purpose of the debugger is to allow you to see what's going on inside of your program while it executes, or at the moment that it crashes. There's 4 main steps to debugging. So typically you'll start your program with some inputs if it has them. You can tell the program to stop at certain places, and then you can examine the state of the program and maybe things in memory, variables, registers, and you can even see things like assembly code for that specific set of instructions. And then you can change things at runtime. So I think this is one of the key factors that isn't in, say, that kind of, oh, I'm going to put a print statement in here. With debuggers, you can actually change the flow of the program. You can overwrite variables and bits of memory. And you can try and experiment and see if you fix the bug, and then you can go on. And my favorite bit of this, and this is actually in the man page, and it says you can try and correct the effects of the bug and then go on to learn about another. Because I don't think there's such thing as bug-free software. You just haven't found it yet. And the good thing about GDB is it works with C, C++, and Fortran, as well as Modular 2, which I actually don't know what that is. But yeah, a lot of HPC codes, again, are written in those 3 languages. You've got Python as well, but for Python, there's like PyDB, but it's very similar. Okay. So yeah, this is a question that you're probably thinking in your head, or like we've all been there. It's like, can't I just use print or printf or insert, whatever your print function is in your language? I'm not going to lie, I still do it. And there's certain places where printf debugging can actually be valuable. And one of them is, an example is, if your code cannot run without optimization, without optimization turned off. So when you're running on HPC, typically production runs, you might specify -02 or -03 or something like that. Okay, and the problem is that you can't have debug symbols when the code is optimized. So if you've got a really horrible memory bug, or you've got some kind of maybe there's a compiler bug, when you compile in debug mode, your code might not crash. Okay, so yeah, debugging is great, but sometimes you do have to go back to the old printf method. And someone on the forum said, "I'll give up printf when you pry my cold dead fingers from it." And it's all about debugging. Another valid approach to debugging is the ostrich algorithm. And this is basically you bury your head in the sand, okay? So the cost of fixing the problem outweighs the downside of the problem. Maybe if your server crashes once every million times, a million requests or something, you might deem that that's fine, we'll just reboot it. Send someone with a stick, turn it off and on again. Valid. So typically in an industry, if the cost is too expensive, then they'll just put up with the problem. Okay, so we're going to jump into a live demo. I want to demonstrate some of the features of GDB and some of the things that I use kind of on a daily basis when I start debugging. So in this talk, I'm going to be, or in my demos, I'm going to be making a lot of use of tmux, and I'm not going to teach tmux today, but it's probably good that you know it exists. So tmux is a terminal multiplexer, and it allows me to basically split screen. So I can create some of this. So I have like a normal terminal, and then I can open a split window with a shortcut. So I'm not going to explain tmux. If you see this kind of stuff happening on the screen, that's what I'm doing. It just allows me to show you different things at the same time without jumping back and forwards. So today I've sort of created the most, it's hard to get real examples for debugging because you never save them and then you fix the bug and then you move on. So I've sort of generated, and also I want you to be able to follow it. So I've sort of generated a very simple piece of code that can demonstrate how you might use GDB. So management have come in and have said, we're going to set a new password policy, and you have to use unique letters from A to Z. You can only use each letter once, and the first n letters of the alphabet for a password of length n. So that's their new requirements on this silly password scheme. And so you've decided to write a code that will tell you if your password's secure. And you've just set some big number here on line 33. And if we're going to do some calculations to work out, how many combinations are possible, and then if it's bigger than that number, we'll say it's safe. Okay, so that's the code. We'll come into the code in a bit more detail in a second. We're going to run it. So I'll make clean so we can see what the make command is. So, brilliant. Oh dear. Okay, great. So it's building two binaries. We're going to come on to the second one later, the MPI one, but for now we're just going to look at the serial code. And I've got the -G. You don't need the GDB bit afterwards, but the -G flag says put debug symbols in, okay? So you'll need that in order to see information about the code when you go into the debugger, okay? Yes.
Is there a difference between -G, GDB, and?
So I was going to check this before the talk because I only started using it the other day.
I've used like G1, G2, G3,
yeah,
G4, but
so
I've not seen GGDB.
Find if it mentions it. We're going to come up with loads of stuff.
Use slash double space -G.
Slash
double space
-G. I'll see if it comes up with the GDB one. Yeah, produce debugging information GDB. This means, most expressive. So it just adds a little bit of extra information. But I normally just use -G and it also works fine.
Yeah.
It just adds a little bit of extra stuff. Okay, so I've compiled it with the debug symbols. And now we're going to run the code and see what happens. So the code is called password.exe. And it takes an argument, which is your password. I'm going to do something else. Give it the full path, and we're going to give it a password ABC, for example. So that meets all the requirements. Password length is 65. password is not secure. Okay, so this looks a bit suspicious. I was expecting the password to be length 3 and not secure. That bit seems right. So let's jump in and see what's going on. So again, you could kind of go in the code, put some print statements in, try and figure out, but we're going to use GDB. So my keyboard's in US. Right? Yes,
Why
question.
did you put the full extension rather than just /
I'll show you in a second, because so I could have launched it with // but this is to mirror what GDB is about to do. GDB is going to launch it with the full path. So GDB, yeah, we'll do it step by step. So first of all you need to pass to GDB is the binary. So it's called
It might be a hint to the bug.
GDB password. .exe. So this is the kind of minimum you'd need to launch your code into the debugger. And before I get started with commands, so I'll just plug something. So I have a little cheat sheet. I'm going to come back to this later on, but this is in my documentation for my MPI debugger. And it's just like some commonly used commands and things that you might want to do. I appreciate the font's a bit small. But yeah, so you'll get a link to this at the end of the talk. And it will be available. So this, I've typed GDB, I'm running my executable, and we get a load of output at the start. I always find this really distracting. So the first thing I'm going to do is show you the -q flag, which is quiet, and it basically launches GDB without all of the gump. Okay. But the other thing is our program actually requires arguments, and there's different ways to pass these arguments in. I can type run ABC, and that's like passing the option like we did up here. Or if when I launch GDB, I can give it this --args. You still give it the name of your binary, and then you can just put the line as you would type it in the command line. Okay. I'll make this full screen for now, readable. And then if we did that, we're now in the debugger. Okay. And one of the commands you can type is list, and that will show you where you are in the code. So so there's so many kind of commands I need to teach just to get started. And then the first one is start. That's going to start your program, but it won't actually continue with execution. It's going to stop at the first instruction in your code. So if I type start, now I type list. We are on line 33, which is this one. So this is the first part of the code. Go back here. This is the first part that has an actual an instruction on it, because the rest is just definitions. This is the first line that actually does something. It sets big number equal to 100,000. Okay. So now in the debugger, I can step through the code line by line. So I can type next, and I can if I keep pressing enter, it will run the previously ran command, and I can keep doing next, and I can just let it run through the code. That's one way to go. But currently, if I do a list, I can see that I'm on line 40 and I'm in this loop. So I'm going to be pressing next for a very long time. So a nice useful function or command is until. So I can say run until, and then I can give it a line number. So I can say run until line 44, and it will run the code until line 44. You can also give it, you can be specific. So in this case, I've got a very simple program, but you can give it file names and line numbers, and you can tell it, oh, I want to stop in this piece of code at this specific breakpoint. Yeah. And another thing you can do is, I just mentioned breakpoints, so we can set a breakpoint. Breakpoints are special markers in the code, so that when you hit that part of the code, the debugger will stop. And for instance, I know the code prints out password is not secure. So I could put a breakpoint on line 20. Breakpoint, I can give it the file name, password.c, and I can say break on line 20.
Just break.
Yeah, break. There we go. Password.c and line 20. And now if I type another command, which is in the cheat sheet, continue, it will continue running until it hits a breakpoint. So continue, and I can type continue, the full thing, or I can just press C and it will continue, okay? But one thing I want to show you that I really like about GDB is it also has a terminal user interface. So sometimes, depending on what you're doing, it's nice to be able to see the code as you're stepping through. So I'm going to quit my debug session, start again. But this time, I'm going to launch it with the terminal user interface, --2e. When I do that, we can see the code as we're executing. So if I type start, it's going to chuck us in at the first instruction, and then I can step through the code. Lovely. We can see we're in a loop, and then I say I want to run until I can set a breakpoint at line 46. You can see there's this B at the side, B plus, and then if I press continue, it's going to mess my screen up a little bit, but it's going to run us until line 46. And now this is capital B. Yes, questions?
How does that work with multiple files? Does it open like multiple tabs or something? Or does it just switch between them as your control flow changes?
Yeah, so because you're in a serial application, the code's only ever in one place at a time. So in codes where you've got like 50 different input files or source files, for instance, if factorial, this function I'm at now, when it steps into this function, if that was in a different file, it would just open that file. Yeah. I'm not sure. To be honest, actually, one thing I'm not sure about is does it open the files because it has debug symbols, so it kind of knows which lines correspond to which parts of the code. But what I don't know is there somewhere a dump of all the source code in the binary, or when you compile it with these flags? I doubt that. I think it just looks up the location.
I think I thought it would have done.
But anyway, the point is that if you have multiple source files, it will just step into them as and when. And that comes on to one of the points I wanted to talk about, which is debuggers aren't just for debugging problems. I use debuggers as a code discovery tool. So as a research software engineer, we're put on many different projects, right? And you want to get to speed with the code, as quickly as possible so you can start contributing. And I actually use debuggers to kind of understand the flow of the program. Because sometimes you think you know what it's doing, but if you jump into a debugger, you can see, oh, actually, it's going to this function and this function. And you can get an idea of the kind of core components of the code. Yeah.
Have you found that practical for like HPC large scale?
Specifically, I mean, like even more so because they're very complex codes with like, you might have 50 different modules and only 3 of them are actually used. And you don't want to read through a million lines of source code. This one's used. Other areas where it comes in real handy, if you're using C or C++ code that's got heavily lined with preprocessor directives, that can be a nightmare to read the source code. And actually, if you go in a debugger, it's already compiled. It knows which pathways are actually the ones it's going to run. So again, jumping through a debugger, it's a much better experience for me than reading source code on its own. But there's benefits to both, but I definitely use it for real problems, real codes. And the larger the code base, the more useful this is as a tool. Okay, so we're going to start now trying to look into some of the problems. And I'm going to restart the program. So I'm just going to type start. I'm going to give it a password again. So I'm going to give ABC as an example. And start from the beginning. Now, the first thing that's kind of strange is our password length says it's 65 when we run it at the top. That's not right. Okay, so let's just try and figure out what's going on. So I'm going to step through, and the point at which we set password is on line 37. So I kind of want to see what password's being set to. So if I type next, I can print, so print can be aliased to just P. I can print password. And what I can see is it actually looks a lot like the name of my executable, okay? And that's just not correct. So what I could do is I might want to see what's in this arg variable. I print argv. It's a pointer. It's a pointer to a pointer. So let's print the first one. Okay, that's the name of my executable. Let's see if there's a second one. ABC. Okay, so my password is the second one. So what I'm going to do is, well, there's different options here. I wonder if this will work. I haven't tried this. I'm going to try it now. Basically, you can I mentioned you can change the flow of the program whilst it's executing, so you can reassign variables. I've never done it with something like this where it's a pointer. I normally just do it with simple integers. So I'm going to try it in the live demo. If it doesn't work, we can skip it. So set var, and then it's password. Well, actually, I can just do it this way. And I'm going to set it equal to ABC. Now, if I print password, hey, it's ABC. Okay, so now let's go to line 44. So I'm going to do run until line 44. And this is where it's going to print the length of the password. So if I print length, 3. So this is why debuggers are really cool, is we've not rerun the program, we haven't changed any source code so far, but we just said, oh, you have an idea, I think this is a fix, I now want to run through and see what happens with the rest of the program. Okay, so I'm now going to just click continue, and this is going to run the program until the end. And I put breakpoints in, actually I'm going to clear my breakpoints. Okay, so I'm going to click continue, and what we get now is password length is 3, password is not secure. Okay, I'm sort of expecting that. Right. Okay, so now we're going to go back to the code and we're going to fix that error. Okay, so I'm going to come in here and we're just going to change password to RB1. Okay, great. I need to recompile it, so I'm going to do my make. Yeah. And now let's try it for a bigger password. So we've tried it for ABC. Let's EFGHIJ, super secure. Password length 10, still not secure. Okay, I think that should be. Let's try something even longer. 13, still not secure. I have a feeling it should be secure and something else is happening. So let's go back into the debugger. And so the command I'm going to run is, I'm just going to give it a slightly longer password, EFGHIJK. Okay. We're going to start, and then if we have a look at the code, what's going on is that we get the password length. That's now correct. Okay, we've just checked that. The password length is correct. So if we go into line 46, we print the length, it's 11. Yeah, that feels right. The next bit of the code is going to say, okay, well, it's going to calculate the factorial, so the number of combinations. And then if the factorial is bigger than our big number, which was like 1,000, we can celebrate, otherwise sad times. Now currently it's going to sad times, and we can check that. If we go next, it's going to do the if statement, and it's going to go to sad times. Okay. Print password's not secure. I don't think it should be doing that. So I'm going to put a breakpoint at line 46. I'm going to rerun the code. Start from the beginning. Okay, and when my screen gets messed up, I'm pressing Control L. The terminal user interface, because we're writing text to the terminal as well as debugging, when my code outputs print statements, it's messing up the TUI. So clear screen, Control L, sort of reset your screen for me. So I think something dodgy is happening here. So I want to step into this function. So I'm going to use S, which is short for step. And that's going to take us to the factorial function. Now, at the start, let's initialize fact, print fact, it's 0. And then what we're going to do is we've got a simple algorithm that's going to go from 1 to the number of, to the length, and then it's going to times our factorial by the number. So we're going to go through, and by the end of it, if we print none, 11 factorial is a very large number. I'm not going to tell you what it is. But it's a very large number. And if I go to the end of this function, so if I finish, print fact, it's still 0. I think something dodgy is going on. So I'm going to rerun my code. We're going to step into it. I'm going to try and figure out what's happening. So step into the code. I think factorial, with this nice hint above, I think factorial should probably be Okay, I think so, but let's play around with it. So we're going to use again this set variable. I'm going to set fact equal to 1. And then we're just going to run this function and just see what happens. So I'm going to say run until line 12, which will be this return statement. And run until then. I'm going to print fact this time. Not set fact. Silly. Breakpoint 7. Program. I think I did it too soon. So if I print fact, I need to set it now. Set fact 1. Yeah, okay. Now I think the problem is I set it on line 7. It then executed line 7. We set it to 0. So alas, we try again. We're going to run it until 12. Now we're going to print fact. Ooh, yeah, that number's looking pretty huge. Okay, so let's just continue with the rest of our code. We're going to do next. We're going to do next. Okay, celebrate. Hey, password secure. Fantastic. So I think that's the bug. We'll go back in and change it. Before I do that though, one thing I want to show you is sometimes, in this case, I was looking for bugs in the code. But when I was talking about code discovery earlier, sometimes you know the code's running correctly, but it's maybe hard to generate the conditions you want to actually check. Okay, so I'm going to quit this. We can launch the code again. What I want to show you is, let's say we're going to run it to line 49. Okay, so we're going to breakpoint 49. Okay, so we're at line 49, and let's say we've got a super complicated code, just like fusion physics or weather modeling or atomic and molecular stuff, and you end up with these two conditions, but one of the conditions is really hard to trigger. Right? It might be a really rare occurrence. But I still want to check that that branch of code behaves the way I expect it. So when I get to this point, I print fact. Fact is 0, so it's not greater than the big number, so it's going to go to this branch. But I want to see line 50. I want to execute that function. So I can just, again, use this set var, fact equals, and then make it. It takes expressions. So I could do big number plus 1. Okay, so I don't need to know what big number is. I can just check that that's worked. And now when I do next, it puts me into this branch of the code. So again, for code discovery or like a sort of human version of testing, it's not automated by any means. Yes?
So you can set and you can add 1. Can you use any other intrinsics or functions from your code?
You can. I'm not going to show it because it's a bit depends how they're loaded in the environment and if they use any other modules or whatever that needs to be loaded. So like in theory, yes, but I'm not going to show you that. Yeah.
Suppose you're stepping through and you find that you should have set argv to 1. Could you edit that in the GUI, or do you have to come out and edit it in the text editor?
Oh no, you can't. This doesn't see. This is not a code editor. This shows you the code. But yeah, if you want to, you can edit when I'm editing variables. What I'm actually doing is overwriting memory.
But as in, you can't say, "Oh, I realised I just need to switch that to 1." I can quickly do it.
Because then it would need to be recompiled as well. And so like GDB is amazing, but it doesn't do that. It doesn't fix all of our most problems. But yeah, what's quite nice here, I typically use debugs, so I'll debug in one side, jump back into the source code, and then I can change it here. So we're going to go up here. And now this is going to conclude for the time being. Let's just check we can run this, make. Now we're going to give it a password is secure. Okay, I think I'm happy with how my code is performing. One thing I'll show you before I move on, actually no, I think I won't have time. So let's jump back into the presentation, and we'll come back to some other stuff if we get time. Okay, so I hope that I've sort of demonstrated some of the benefits of a debugger. So what was really important to note is whilst I was in the debugger, no source code has been modified. I can make changes, I can test things, I can print as many variables as I want, but I haven't changed any of the source code. And that's really important because I've seen this a lot like in the wild where I have memory bugs, and actually the act of adding a print statement can change the flow of the code. Yeah. So you change how things are laid out in memory, and then you're no longer triggering the same problem. Okay, and the code might run absolutely fine. Sometimes as well, I had a recent example where I was putting in a printf statement in a C++ code, and all of a sudden my test all failed, and I realized my printf statement was badly formed, and it just led to other problems. If that was in the debugger, I wouldn't have had that problem. Program execution can be overridden. It's terminal based. So HPC codes, like I said, they run typically on supercomputers. So I could have logged into the SSH to my supercomputer and run all of this stuff locally. The other key point of that is, even if you can run your program on your own machine, chances are you possibly have a different operating system. You've got different libraries installed, different dependencies, and all of these things could affect whether or not you see the same bug. So that's why I really like going for a tool like GDB. I haven't showed you this yet, but bug sessions can be scripted. So you can write a list of the commands that you want GDB to run, and then you tell it, hey, execute these commands at the start, and it will just do the whole debug session. So that's really good when you're making little changes, and you say, okay, you don't want to reset all your breakpoints every time. You don't want to reprint all the variables. You can just tell it, hey, run this script, and it will run through the whole code for you. It's flexible and powerful. There's so many features I haven't even had time to cover. Hopefully I'll cover some more in a bit. And you can use GDB for code discovery. So one thing I really like doing is I jump into a huge code that's got like thousands of source files, and I'm in some deeply nested function, and I'm like, where did I get called from? Jump into your debugger, you set a breakpoint, you run it until the breakpoint, type backtrace. It will give you a complete backtrace of where you are. That's super helpful. I'll show an example of that hopefully in a minute. That's really, really helpful. So I now want to come on to talk about MDB, which is my kind of MPI-aware debugger. I basically completely borrowed heavily on GDB. I didn't want to reinvent the wheel. So the whole purpose of MDB, and the M's for MPI, is that you have the familiarity of GDB. You're still using GDB under the hood, but you kind of get some quality of life improvements for debugging parallel codes. Okay. Has anyone here tried debugging MPI program before? A couple of hands. Can you tell me how that went?
It's a bit painful. It can be painful.
Yeah.
It was a program that I had total view,
Yeah.
and we had a license for total view that was the size of the program we were running.
Yes.
Very expensive.
Yeah. Okay. And what about yourself?
Doable. It was either GDB with Xterm, or I did something that was appallingly hacky, but involved GDB with screen and MPI things.
Yeah.
I have no idea what your solution is. It's probably far better.
Well, yeah. So I'll come on to some of those equivalents, but basically, yeah.
There's also a hand up if they want to comment. Bryn Ubald raising their hand.
Yeah, please. Can we hear them? If they say
Yeah, if you want to unmute and tell us your experience, please do.
Yeah, it was pretty much the same as the above, but attempting to use GDB and screen. And also a bit of a different approach when it came to Python as well versus Fortran and C++.
Yeah, so I'm not going to cover Python. Some MDB and GDB don't support Python. They use Python, some of them, but yeah. But in terms of the other experience that you mentioned, screen. So I'd seen a similar thing, but for tmux. And there's things I love about it, and it works in some cases, but there's other things that don't work so well. So I'll come on to that in a bit. Thank you. So we're going to go for a live demo of the tool. But a couple of things I want to show first is I've gone through some considerable effort. First of all, the tool is open source and freely available. It's hosted on GitHub. The link's at the end of this talk. I've gone to some lengths to write quite a lot of documentation. So there's a read the docs. I showed the cheat sheet slightly earlier. So if nothing else, you can use MDB as a cheat sheet for GDB. But it covers like installation, and it currently only supports Linux or Unix. And there's also a quick start guide. And this is I'm basically going to cover this. It's basically a tutorial. It shows you how to run the program, what commands to type, and what the expected output should be. And that's kind of what I'm going to run through now. But if you want to do it in your own time, you can. Basically, the example binary stuff is in here in the examples folder. You can make it, and you can follow along whenever you want. There's also a man page that gets built if you download, if you do the developer install, you can build the man pages, and that's also a version of the documentation. And it has how to run it, commands that suddenly got messed up, and some useful information. So we're now going to be looking at a different program. So this one's going to be a Fortran program, and it's it's a Fortran program, and it uses MPI. Okay, so unfortunately, GDB only works for serial applications, unless you do kind of one of these hacks we mentioned, where you launch it in 4 different terminals, or you use screen or terminal multiplexer. Okay. So the goal is we want to be able to debug MPI applications in a kind of like similar to GDB. Okay. I'm going to run the program, and we're going to see some issues. So okay, it's already made. Yeah. So the way to launch MDB, it has kind of 2 modes. So it has like a launch and an attach. And so to launch it, we're going to use this command. Okay, and my demo already. There we go. What this does is it's basically going to launch so I told it to launch 8 versions of the code. So MPI launch -n8. Should probably show you how to execute the code normally anyway. Let's do that. So my binary is called simple MPI exe. And let's say I normally run it on a system with 8 processes, and this might be how this is like how I normally launch my code. So I run it, it does some stuff, sleeps, and then it prints out some information, and then there's a problem and it crashes. Okay, I don't know which process is crashing. I don't have any useful information. I've got a little bit of a stack trace that I could look into, but I want to kind of look at this with a debugger so I get a bit more information. It's a bit more user friendly. So that's kind of the issue. So it's always hard to kind of show everything, all the stuff on the screen at the same time. But this was the command that we ran to run our program, and I want to show that there's a similar syntax to run it with the debugger. So you use mdb launch -n8. -n8, this is like 8 processes, and then your binary. Okay. I don't think I need got slash either. It's still one thing I do have to do though is I have to kill my GDB instances. Okay, so now what that's done is it's launched 8 versions of our code through GDB server. And then in order to connect to that with the debugger, we would use mdb attach. And one nice thing is MDB, I wrote it with click, which is a Python package, and it has autocomplete. So you can, I've got in the home directory, in the root directory of the repository, there's a completion for bash. You can do it for other shells as well, I think like Z shell and fish, but I haven't included those yet. But again, and also I can type mdb attach help, and that will give me some information about what the commands I need to type are. But in this case, it's nice and simple. I'm going to do mdb attach -n8 simple exe. Now, I'm also going to tell it to make a breakpoint at main. And in Fortran, when compiled with gfortran, the main is called this. In C, it's just called main. It's more of a Fortran thing. I don't have to worry so much about. But what this is going to do, if I can spell unexpected argument. Oh, I put it in the middle. Oh, I don't even need the binary name. I don't know why I'm giving that. So we've already launched it. So when you launch the debugger, that's when it actually launches your, that's the one that needs to be run with your binary. When you attach, you don't need that. Okay, so now what it's done is it's connected to those, and we can start kind of, I want to show you kind of first the similarities between GDB. So full screen. So because you've got a parallel program and you've got 8 separate processes running, I've tried to think of a way to kind of control those in a sensible manner. And so what I've done is I've got this command called command, do help command. And what it does is it will run a GDB command on all the processes, one after the other, or at the same time. If I do command list, every single process is going to tell me where it is in the code. Okay. Likewise, I could do this one, and it can tell me where it is in the code. Okay, so I can start stepping through the code by saying command N. Okay, and then it's going to do, just like we did in GDB, it's going to step through the code every line. Yes, question.
I mean, seems a very unlikely scenario, but if your tool becomes incredibly popular, what happens if, you know, multiple... But okay, well, unlikely, at least initially, but I meant if there's multiple people running an MDB session with on the same, say, login node or something.
Yes, so this is a very good question because in theory it shouldn't matter, but it does at the moment. And Casper very nicely sent me a message about 2 hours ago saying, basically to give a warning, don't run this on CSD3 yet, because I think the way it's set up, I don't fully understand. He did tell me, and I've sort of forgotten, but it launches on localhost, and so someone else could connect to your session and control it. So I am going to work with Casper for a solution to that. I've got already an idea of how I could do it, but just change, instead of using GDB server, I might control the GDB process myself. But in short, it shouldn't be a problem. At the moment, it currently is, especially on CSD3. And so Casper just told me to give a warning, don't run it there yet. But locally, you can run it, and it works like fine for me and a couple of other people that have tested it. I'm going to work on a solution that is more friendly for multi-user environments.
And that's true. That's true. That's not just the login nodes. Even if you run on the compute nodes, that's.
So if you have, yeah. Well, again, I don't fully understand the networking side of it, so I'm going to chat to Casper and hopefully get some more information on that. Yes.
A completely different subject, just looking at the screen there and thinking my experience of Dish and particular shell, and particularly Dish back, which does the summarization. So you've got 8 sub-processes at the moment, and that sort of fits on the screen. But if you're debugging a 1024 range program, 1023 variables, you have the right answer, and there's one that's different.
Yeah.
Is there a UI tweak that you could make that would,
So there's things I have that, so for instance, one of the things I'll come on to now is I can tell it that I only want to do stuff, say on processes 1 to 3, or I could do like 2 and 4 to 7. Right? You give it list and hyphen and comma separated lists, and this will do, you know, okay, so that answers part of the question. But yeah, so I can select specific ranks and tell them to just sit in idle mode, like sit in continue mode, and then they're not going to be printing to the screen every time. So if I select and do like that's the first 3 ranks. And what I'll do is I'll set the others, which is 3 to 7, to sit and continue in the background. Okay, so now they're not going to be posting output to my screen, and if I do things like command next, it's only now going to be ranks 0, 1, and 2. Okay, so I'm just going to kill that because it's the end of it. But yeah, so there are kind of things around that. I'm trying to think of some other holistic tools. So one of the ones I'm going to come into now. One really cool thing about this MDB that isn't in any other debugger that I've found so far, parallel or otherwise, I don't know, parallel I should say, for MPI programs. With the launcher, which is MDB launch, you can add an extra flag, -R or -auto restart. And what this will do, when you're debugging MPI programs, because of init and finalize, you can't just restart the program midway through. It's an undefined state and it crashes. Likewise, if any single one of the processes dies in that session, all of the others, you can't debug them anymore. Okay, so this can happen. Yes.
A question from Simon Clifford, if he wants to unmute.
Please.
Sure, it would be quite nice if that output was sorted, or at least sorted in the order of the command that you provided, because otherwise you're hunting through it to find rank 25 or whatever.
Exactly, and it's that for me is quite easy to do actually. I haven't done it yet, but sorting the rank output at the moment, I've just prefaced the rank so that it says, "Oh, this came from rank 0, rank 1." It's kind of trivial for me to sort it, or likewise, I'll come on to at the end. But if you want to submit a pull request, the code's all on GitHub, and I'd be more than happy to review that. But yeah, I definitely is something that I can add. And likewise, if anyone wants to raise any features they would like to see, if you raise an issue on the GitHub, and I'll also look at that for like feature requests. So let's get back into the demo. So with the auto restart, if I run my program and let's do some stepping, and I go, oh, I've gone too far. I want to step. I want to go backwards. You can't go backwards in an MPI program. So the best you can do is I can just kill this session. Kill it, but the job at the top's auto restarted, so I'm already ready to connect again. So I can just jump back in and start my debug session. So that's just like a nice quality of life feature. I haven't seen that in any other tool that does the MPI debugging. The other cool things I like is, so I'm going to make this full screen now. Like I said, it's essentially just wrapping GDB, and so sometimes maybe I step through a little bit. And I'm just going to pass the initialize. Yeah. So I'm inside my code somewhere, but now I kind of just want to go to one rank. I know roughly where the problem is, but I just want to go into like my familiar GDB shell just for this rank. So I've got a command called interact. I can tell it a specific process to go to. I might go to process, let's go to the first one. And now I'm in GDB. The prompt's changed. It used to be MDB. Now it's GDB. I'm now inside of GDB. So I can use GDB commands. So if I press Control XA, it opens up the TUI of that GDB session. So you can do this in GDB normally. I showed the -- TUI, but the shortcut is Control XA. Okay. Yes, question.
I have a very quick question. Can you use, so like say Intel have their own fork of GDB for bugging, on their GPUs, like GDB 1 API or something? Can you use their custom GDBs?
Yeah, in theory. So their GDB, so AES, you can use their GDB. You'd have to change. At the moment, I don't have a generic thing that allows you to use any debugger, but again, that's a trivial change in the Python script that would change which debugger it launches. One thing I was going to mention is Intel do package their own MPI aware GDB. It handles it in a different way, and one of the things I don't like about their MPI version of GDB is they've lost the ability to Control C. So Control C should interrupt the execution. So you can run your program. So if I type continue.
I have to go, but thank you very much.
Thank you for your question. So if I type continue. Oh, and by the way, the other thing that's good about the interact feature is now in GDB you get all the type completion stuff you might have. I want to set a break. What's this? I can tab complete, so it knows that these are functions. It will know that there's the source code thing, and there's all these different things I can get from tab complete. Again, I haven't seen this in another MPI debugging at all. You lose some of these features. Also, the way that I love the same different things. Got 5 minutes left, so I do want to get. No, that's all right. I do want to get some Q&A. I just want to try and show some more features. So in this case, let's talk about it. I have a bug, so I'm going to come out of the GDB mode. So Control D will quit out of GDB. So I'm now back into the MPI debugger. I still have my bug. I haven't fixed that. I haven't even found it yet. So what I want to do is just show you how I might find a bug in my code. So if I let the code run, it's going to crash. Okay, same as it did before. It's automatically restarted the job. And if I try and do a backtrace, I've probably got nothing. Command backtrace, because it's ended the session. What I want to do is tell it to catch it on exit. So when it fails, I want it to make a breakpoint. So I'm going to rerun my GDB instance, and I'm going to say command break on exit. Okay, so this is the breakpoint that will get called when it tries to quit out of the code. And now if I do command continue, it's going to run the it's going to run the code the same as it did before, but now I should still be in MDB. Yeah. So if I do my command backtrace, I now get a backtrace because I'm still in the debugger. And what I want to show here is I've got a holistic function or command. If I type status, it tells me all of the processes that are currently at a breakpoint. Now, the breakpoint I said was at code exit, but one of them is red, and it's different to the others. Basically, they're in a different space. So what I'm going to now do is do a command backtrace on process 3, and I'm going to find out where it is. Okay, so now if I go back to my source code, which has been squashed over here, make this full screen for you. Well, before I do that, it was line 40. We go into our source code, and there's different ways to do this actually. One nice thing actually, let's stay in the debugger. So I'm going to do interact, and I'm going to go to the process that's demonstrating a problem. I'm going to open the TUI. Now it doesn't know where we are because we're in some deeply nested function. So I do backtrace. We're at the bottom of the stack, but I can press up, and if I keep typing up, eventually it will get to the first bit of source where it knows what's going on, and that's my code. And I've got a deallocate statement. And if I go, that's fine. But if I go back to the source code, that was happening at line 40. And we can then start to have a look at like, oh, okay, what's going wrong? So something happens for process 3 that doesn't happen for the other processes. I can see above, there's a special function call, special for rank 3. And if I go to that, I might get a hint. It looks like it's also deallocating right there. So this is, yeah, something I kind of want to say quickly. I think that I should call time on that. And now, yeah, I want to jump back into the presentation. Okay, so I just want to talk a bit about some of the benefits that, as I see them, to MDB. So it's by no means ready for release yet. I think I'm in like close to a beta or something like that release. So I definitely like people's inputs, and if they want to test out the tool and try it out. Although, as Casper said, not on CSD3 at the moment, and so I have to figure out a fix for that. But yeah, so soon you should be able to debug HPC code where it is. I mean, there's nothing you can use the tool; it's just not secure. So don't do that. And it's a problem with GDB server. It's not to do with my code. It's a problem with GDB server. So yeah, you get restartable sessions for MPI code, which I haven't seen. So someone else, please correct me if you can see that. You can script the debug sessions. That's in documentation. So I didn't cover it now, but at the end of the quick start guide, it tells you how to do scripting with MDB. It's very similar to GDB. So if you learn it for GDB, it's kind of the same thing. You just pass this flag and then the commands that you would have typed out normally. And if we get the slides. Okay, there's some holistic commands. I call them holistic, so they're like summary commands. So things like status, info. Oh, I didn't even show the plots. You can plot variables. I do really want to show that. Let me come out of that because it's a really nice feature. And this comes back to something that Chris just mentioned earlier. I'm going to relaunch the program, this feature, and I'm going to step through a little bit. So I have, I can show you the source code. I have a variable on line 16, and it's set to 10 times the process rank. So what I want to do is go to that line. So command use 16. Okay, and if I do command, just show them. So we're now on line 16. So if I was to print variable, they should all be 0. And then when I execute line 16, they should all become 10 times process rank. But I've got this holistic function called or command called info, and if I do info var, it will produce a plot. Now at the moment there's 0, so there's no plot. If I step through one line, yeah, you now get a plot of all the variables. Thank you very much. And what's really good is if I do info, check the name of the variable. So there's one called size of cluster. So this should be a constant. So if I do info size of cluster, there's 8 processes, so it shows you a constant flat line. And where this is really good is you can set one of them. This is arbitrarily, I'm going to set one of them equal to 4. Set variable equal to 4, just to demonstrate a feature, to demonstrate why I think this feature is useful. So if you've got a number in your code that should be a constant across all processes, and maybe it's been overridden by a dodgy memory, or something's got corrupted, or it's done something strange, holistic plot from being able to plot the variable across all the ranks, you can immediately see there's an issue on rank 2. Okay, so you don't need to inspect every individual rank. You can just get a kind of overview of the code. And if anyone who's wondering, well, how's that going to scale when you've got 1,024 processes? You can change the plotting library from the terminal graph to matplotlib, and then it will, obviously then you'll need X forwarding or something like that, but then you can see a much more user-friendly, like a plot that's not going to take 1,024 lines. Okay, so that's what I really wanted to demonstrate. I need to wrap up. There's a lot more. Please, I've mentioned some of the other tools and why I do or don't use them, but you can click through them and have a look at those. And then I just wanted to say a special thanks to Fergus and Rosie, who's in the picture, because yeah, he's been really, he's already submitted a pull request and that's already been accepted, and he's got another feature that he might be helping me to work on, and just for generally being excited with the project and encouraging me. And yeah, there's a read the docs. You can have a look at how to run the example, and there's also the GitHub if you want to download the code and play around with it. Thanks very much.
Thank you very much, Tom. Looking at the time, I suggest we finish there and then we can continue with some questions informally afterwards. But yes, thank you everyone. Tell all your friends, get in touch, submit pull requests and issues and everything else. And please join us next week when we've got Jasmine from the computer lab talking to us about different approaches to software architecture. So yes, thank you, Tom, and we'll go for some questions.
I'll just say, if anyone online has a question, chuck it in the chat and I will reply to you. Obviously, if put an email there as well if you're not, yeah, I don't know who you are, but yeah, put your questions in the chat if you have any, and I can reply to them.
I mean, I think we can probably hang around for a couple of minutes now, but I just like to wrap up if people do need to.
Yeah, if anyone needs to go, feel free to leave. Otherwise, if there's any questions, I'm happy to take them.
Yeah, there's one from Sherman Lowe online.
Yeah, please feel free to ask a question.
Hello, Sherman speaking.
Yeah.
Oh, hello. Yeah, so hello, I'm Sherman from Queen Mary University of London. So thanks for the live demo. I'm just wondering, like some HPC facilities use like a scheduler. So if you use like a debugger tool, would you request an interactive session, or is there a way to use the debugger tools when you want to submit a job?
Yeah, so currently I haven't supported, so currently it's not super hard, but I haven't put Slurm, for instance, Slurm or PBS into that tool. And I'd have to write just a little bit of template around that. But what you can do is do if for instance on Slurm or the others, do an interactive session, launch it with MPI run or MPI exec, and it should behave just as I demonstrated. But I am hoping to add things like srun to it soon, but it just requires a bit of work. Yeah, thanks for that question.
Cheers. Yeah, cheers. Thank you for the answer. Thank you.